Hello everyone. Today we are going to discuss a unit first from the ninth class, that is matter in our surrounding. Okay. Uh, First, what is matter? Matter is anything which occupies a space and have mass is known as matter. It means any substances which can occupy the space and which have the mass is known as the matter. You can take the example stone, table, chair, pen, book, whatever you can take that are made up of the matters. Matter is made up of a tiny particles, small particles, we can say that. Here we are going to classify the matters in many ways. Here we can see there are the three things or the three old knowledges or basically chemical based on the physical state, based on the chemical composition in the earlier eras. According to they have classified the matters. Here first we can see that earlier Indians philosopher classified in the form of five basic elements as air, earth, fire, sky and water that are known as the Pancha Tattva. Means Indian philosopher believed that there are the elements are in the five state. That is first one is air, earth, fire, sky and water. These are known as the Panchatattva. In second point, if we see on the basis of the physical state, the matter is classified as a solid, liquid and a gaseous. Today we are following these basic physical state of matters. We are going to see there are the matters in the solid state, in the liquid state and in the gaseous state. If you see the third point, on the basis of the chemical compositions, matter is classified as pure substances and the mixtures. Pure substances may be element or the compound. Element means you can take the hydrogen, you can take the helium, you can take the carbon, you can take the oxygen. If you come to the compound, you can take the example for the H2O, H2SO4, sulfuric acid or the water. These are the according to the chemical composition. Mixture may be the homogeneous mixture or maybe it is a heterogeneous mixture. We saw there are the three types. We are going to classify the matters here according to the Indian philosophers and according to their physical state and according to their chemical compositions. Okay, if you move further, the states of matters. The matters exist in the three different states that are the solid, liquid and the gaseous. We are very familiar for these 3 points here, or the three states of matters. We see the solid matters, we see the liquid matters, we see the gaseous matter. If you come to the solid, we can take the example stones, bricks. If you come to the liquid, we can take the example of water. And if you come to the third point, gaseous, we can take the hydrogen gas. There are the basically three types of matters we are going to see, that is the solid, liquid and the gaseous. And if we see the properties of the solid, what are the properties of the solid? If you see the first point, solid have definite shape and fixed volume. It means solid have the definite shapes. We can see the shape of the solids and we can measure the volume of the solids. Okay, bricks have the shape. We can measure its volume. And second point, the space between the particles is a very minimum or is minimum. It means there is a very negligible space between the two particles present in the solid state. We can see the picture here below this sentence. There is no space or the very little space we are going to see in between the two particles. Third point, the force of attraction between the particles is maximum in the solid. every particles in the universe having the force of attraction in between them. If we see in the solid, there is the maximum force of attraction between the two molecules or the two particles present in the solids. So they have tightly bonded to each other. And fourth point is that the movement of the particles is minimum in the solid. If the particles start to move in initial position or in its initial position, it's having the very little place to show the movements or to show the vibration. And fifth point, there is a little least compressible. We can't compress them. It's having the very least compressing capacity or the ability. And the sixth point is that there is the rate of diffusion is a very least. Diffusion means the spreading in the atmosphere or some other medium. In the solid, the diffusion process is a very least, we can say. Okay, these are the properties of the solid. If we see the properties of the liquid, the first point is that liquid have no definite shape but have the volume. Mean liquid it not have definite shape. It take the shape of a container. If you fill the liquid in the glass, it take the shape of the glass. If you fill the liquid in the bottle, it take the shape of the bottle. If you fill the liquid in the jug, it take the shape of a jug. It means it does not have the definite shape, but it's have definite volume. We can measure it in the form of liters. In the liquid, we can take the oil. We are going to measure it in the kgs, even though it having the liquid state. If we going to measure the volume of the water, we are going to measure it in the liters. When we go to the shop, we are going to say them, give me the 1 liter of a water bottle. Right? Second point, the space between the particle is intermediate, or it having the little bit space between the two particles in the liquid state. They can slide on each other. They can move from one place to the another place. If you throw the water on the floor, they start to spread on the floor. The water start to flow on the water. It means the particles can slide on each other. Third point, the force of attraction between the particles is the intermediate. It means there is a force of attraction is there in between the two particles in the liquid, but it is the weaker when we are going to compare with the solid. In the solid, the force of attraction between two molecules are the high or the maximum. If we compare the liquid, that the particles between the force of attraction between two particles is a very weak. But there is a force of attraction. We can't say that there is a no force of attraction between the two particles. There is a force of attraction, but it's weaker when we are going to compare with the solid. And fourth point, the movement of the particle is intermediate. It means they can move, they can show the movement, they can show the vibration, they can move from one place to the another place. So I told you the example, when you throw the water on the floor, it start to flow all over the floor. It means the particles of the water can diffuse. It means the fifth, they are less compressible. We can compress it, but it is little bit only we can compress the liquid here. Then the sixth point is that the rate of diffusion is more than the solid. It means the solid can't diffuse, but it having the least capacity of the diffusion in the solid. If we see the liquid, it having a more capacity of the diffusion. It means they spread all over in the area. Okay. Third, Third state of the matter is gas. If we see the first point of the or the first property of the gas is the gas have definite shape or the fixed volume. Means the gas not have definite shape. This is also not have the definite shape or the fixed volume also. Gas occupies the whole space of the container. You can take the example balloon. When you blow the balloon, the particles of the gas cover all the space of that balloon. I will tell you the very familiar example here. When you are going to crush the plastic bottle and you are going to blow the air by your mouth in the bottle come in its initial position or in its initial shape. Why? Because the gas you blown in the bottle, it take a whole space of that bottle. And the second point is that the space between the particle is a maximum. When we are going to compare the space between the two particles in the solid is very least. If we see the liquid, the space between the particles is there, but no, if we compare to the gas, it having the more space between the particles. When we are going to compare with the solid and the liquid, having the more space in between the two particles with very weak force of attraction. Next point is that only the force of attraction between the particles is a minimum. It means there is a force of attraction, but it's very weak when compared to the liquid and the solid. The movement of the particle is a maximum in the gases. While they are free, they are independent in the atmosphere, they can move from any place to the other place. And they can show the very maximum vibration or they show the maximum movement when compared to the liquid and the solid. The gas are most compressible. We can compress the gas in any container. We can see the LPG gas which we are going to use in our kitchens for cook the foods. What is that? That is a liquid gas. We are going to compress it in the cylinders. Oxygen cylinder in the hospital, we compressed the oxygen gas in the container. We can compress the gas here. It having the property of a compressible. The rate of diffusion is more than solid and liquid. When we compare the diffusion properties to solid, liquid, gas having the more capacity of or the more eligibility of diffusion. For example, we can take that if you are going to place a candle in the corner, fluorescent, what we call that, agarbatti in the corner of your room, within a few minutes we smell the pleasant smell of that agarbatti in the another corner of our room. It means it diffuse faster than the liquid and solid. These are the properties of the solids, liquid and the gaseous. These are the three states of the matters. We are going to see the physical nature of the matter. Not only the solid, not only the liquid, not only the gases. We are going to see all the three natures of the matters here. Matters are made up of particles. As earlier I told you, before only I told you the matters are made up of particles. The particles of the matters are very teeny. It means teeny means very small in the size. Next, third point is the particles of the matters have space between them. In all three states of the matters, we see the space between two particles. There is a space between two particles in the solid, but it is the least. We see the space between the particles in the liquid. We see the space between the particles in the gases. And the fourth point is the particles of the matters are continuously moving. It means in the solid, in the liquid, in the gaseous, the particles are in the moving state. Or we can say that they are in the vibration mode. In all the three states of the matter, the particles are in a moving state, or they move continuously, they are in the moving. The particles, fifth point, the particles of the attraction each other. It means the particle attract each other. They are having the force of attraction between each other. These are the physical nature of the matter. The matter is made up of very small, tiny size particles. Next point, the change of a state. Look here, this is a very interesting point here. We can see that when a solid is heated, it changes into liquid. We can take ice here, ice cube. When you take the solid ice cube and start to heat it, and it convert into liquid. When a liquid is heated, it changes into gas. And what the solid ice cube, which is become liquid after heating, if you continue the heating, that water start convert into the vapors. You can stay in the steam. It means when you heat the solid, it changes its state into the liquid. When you start to heat the liquid, it changes into gas. It means solid can change its space, change into the liquid, liquid can change into the gas. When a gas is cooled, it changes into liquid. When a liquid is cooled further, it changes into solid. Okay, this is a very familiar example we can going to see here. When the water is evaporated from the surface of the ponds, rivers, lakes, in the form of vapors, it reaches to the atmosphere, upper atmosphere of our earth, where they start the steam or the evaporation start to become cool, and it take the shape of a liquid. Or best example, we can say that you are carrying the tiffin box to your school. From home you are taking the hot food to the lunch for the school or colleges. When you are going to open the lid of your tiffin box, you see some water drops are attached to the lid inside in the inside of the lid. It means the steam which is came out from the food, that is cooled by the lid of your tiffin box, and the steam is converted into the liquid. It means when a gas is cooled, it changes into liquid. When a liquid is cooled, it changes into solid. You can take the fridge of your home for example. There is a box up in the freezer or the refrigerator. You are going to make the ice cube. You take the shape of that plastic container. You are going to fill the water in that cube boxes, and you place that cubes structure in the freezer. After hours or the 2 hours, we see the water is converted into the solid ice cube. It means here the change of a state of a matter we can say here. Solid can change its state into the liquid, liquid can change its state into the gaseous. And the gas, when we cool it, change its state into the liquid. When liquid is frozen, it changes into the solid again. They are in interchange. We can take the example here below, the state of a change of changes of a state here. First one is ice. Ice, when we heat it or when we melt it, it convert into water or the liquid. When you heat that water further, when you give that temperature to the liquid, it start to become the evaporation in the form of a steam, that is nothing but a gas. When you are going to collect that gas and condense it, condensation, this is the process or the phenomena we can say. When you when you collect the gas and when you condense it, it again change into the liquid. And when you when you freeze the liquid, it changes into the solid in the form of a ice cube. This is the change of a states of a matter. Orally we can say that the solid changes its shape into the, or solid is change its state into the liquid, liquid is change its state into the gas, and gas, when you cool it change into the liquid, and when you freeze the liquid it change into the solid. Okay, next point, that is the melting, that is fusion. When a solid is heated, the particles begin to vibrate with greater speed and begin to move more freely. It means when you heat the solid, the particles present in the solid, they start to vibrate speedily. If you continue the heating, they move more and more freely. Then at the particular temperature, the solid melts and changes into the liquid. The process of melting is known as, or it is called as a fusion or melting. Look here, you can take the ice cube, hold it in your hand. After the few minutes, it start to melt at a certain or at a particular temperature. That is known as the melting. At what temperature solid start to convert into liquid, that is known as the melting point, or we can say the process of a melting. Okay, melting means, or the fusion means, when a solid is heated, the particles being to vibrate with greater speed and being to move more freely than at a particular temperature. Particular temperature means some solid melts at the 100 degrees Celsius, some solid melt at 0 degrees Celsius, some solid melt at 20 degrees Celsius. It means at a particular temperature, the solid melts and changes into the liquid. The process of a melting is known as a fusion or a melting. Here in the below picture we can see their ice cube will start to melting at the 0 degrees Celsius. The melting point of the ice, the melting point of the ice is a 0 degrees Celsius. Okay, next, this is a very important point of this chapter, that is the latent heat of a fusion or a melting. We can say that the amount of a heating energy required to change, or the amount of heat required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is called the latent heat of a fusion. It means if you want to melt, if you want to fuse the 1 kg of a solid at atmospheric pressure, the amount of heat energy, or the required heat energy, at what amount of heat energy 1 kg of solid convert into the liquid at atmospheric pressure. That is known as the latent heat of a fusion. For example, we can take here, if 1 kg of ice, you want to melt it or you want to change the state of 1 kg of ice cube, you need some amount of heat energy. It take near about, we can take that 5% or 5 degrees Celsius. At the temperature of 5 degrees Celsius, with the 1 kg of a solid is converted into the liquid. The temperature is measured in the degree Celsius. It means if you want to melt, I am telling the example. Okay, if you want to melt the 1 kg of ice cube, we need 5 degrees Celsius of a temperature. This is known as the latent heat of a fusion. I hope you getting point. And second thing is the boiling. When you start the water, it start to boil after some time. You are very familiar for this. When you are going to prepare the tea, when you are going to prepare the food, or when you are going to cook the rice, you see the boiling of water in the utensils or in the vessels. Then we see what is the boiling here. When a liquid is heated, its particle being to move even faster. When you start to heat the liquid, the particles present in the liquid start to move very faster in that liquid state. Then at a particular temperature, the liquid being to boil, means after reaching particular temperature, the liquid start to boiling and changes into gas. It means vapors. You can take the steam also. At certain temperature or at a particular temperature, the liquid start to boil. Here we can see that the boiling is a bulk phenomena. It takes some temperature. It takes some time to boil. When a liquid boils, the bulk of the liquid changes into vapors. When you start to boil the water in the vessel, the lot of the water start to evaporate from that vessel. The temperature at which a liquid start boiling is called boiling point. We get the example of a water here. Water start to boil at 100 degrees Celsius. When you increase the temperature of that vessels to 100 degrees Celsius, then the water start to boil. It means at a particular temperature, the water or the liquid start to boil. That is known as the boiling point of a liquids. Different liquids having the different boiling point. Next, the latent heat of evaporation. The amount of heat required to change 1 kg of liquid into gas. We can take the example of water here. Why? Because water is a very familiar to us. Why? Because we are going to use the water in every day-to-day life. From morning until we sleep. We take the use of water in the morning to wash ourselves. We take the use of water to wash our clothes. We take the use of water for the drinking. We take the water to cook the food. That's why we are going to take the water, because it is a very familiar to us. The 1 kg or 1 liter of the water you want to evaporate or you want to make it evaporate, you need 100 degrees Celsius. Before of boiling point. After the boiling point, the water start to evaporate, vaporization. Means the 1 kg of a liquid convert into gas at atmospheric pressure at its boiling point. That's why I told you 100 degrees Celsius. That is the boiling point of a water. Is called the latent heat of vaporization. Let's see here. Okay, 1 kg of a liquid. It means we can take as a definition here the amount of a heat required to change 1 kg of a liquid into gas at atmospheric pressure. At its boiling point is called the latent heat of a vaporization. Okay, next, that is the sublimation. This is a very interesting point, and we are going to perform this experiment every day. Those we are believe in the God, we are going to do this experiment every day. Even some of us we are going to do this experiment morning and even evening also. Here what we see, the change of states directly from solid to gas or from gas to solid is called sublimation. Sublimation means the change of a state of matters directly from solid to gas or from gas to solid is called sublimation. We can take the example of a burning of a camphor. We make a puja every day in the morning. We burn the camphor in front of the God. Camphor is in the state of a solid. When we burn it, when we light it, it directly convert into the gas. It means the solid do not change its state in the liquid first, after it in gas. Instead of that, the camphor directly converted into the vapors. That is known as the sublimation. In the picture here we can see the below, that is the burning of a camphors. Every day we do this activity in front of the God. We are going to pray in front of the God that please God fulfill my all the needs, all the dreams. I am going to pray for you every day by burning the camphor. The camphor is in the form of a solid which after burning convert into directly in the gas. And we see the definition also here. Sublimation is the phenomena by which solid is converted into gas directly. It means we can see here the reaction here. This is the solid here. Solid is directly converted into the gas, that is known as the sublimation. And it is a reversible reaction. We can see here the gas is directly converted into the solid, that is known as the deposition. We get the extra knowledge also here. That is when the solid is directly converted into the gas, that is known as the sublimation. When gas is directly converted into the solid, that is known as the deposition. I hope you getting my point here. Next point, effect of pressure on a gas. What are the effects of a pressure on the gas? Let's see. When pressure is applied on gas, the particles come closer and the gas change into liquid. When we are going to apply the pressure on gas, the particles present in the gas are start coming closer to each other and slowly the gas start to convert into the liquid. From gaseous state to it convert into liquid when we apply the pressure here. Okay, we can liquefy gases by applying the pressure. And reducing the temperature. We have to reduce the temperature and we have to apply the pressure, then the gas slowly start to convert into liquid. The best example is here, the compressed solid carbon dioxide is called dry ice. It means compressed carbon dioxide is nothing but that is dry ice. If the pressure is reduced, if you slowly start to reduce the pressure of the solid carbon dioxide, it changes directly into gas without coming into the liquid state. When you take the dry ice, when you reduce the pressure from that dry ice, the dry ice is nothing but a carbon dioxide. It directly convert into the gas without coming into the state of a liquid. So solid carbon dioxide is known as a dry ice. Next point is the interconversion of the three states of the matter. Why? Because solid can change its state into the liquid, liquid can change its state into the gases, gas can change its state in the liquid, maybe directly in the solid, and the liquid, when we freeze, it start to convert into the solid. This is the interconversion of the three states of the matter. The matter can be changed by changing the temperature or pressure. When it will change its states, when the matter change its states, when they show the interconversion properties of matters, when we start to change the temperature or pressures. Here we can see here, when liquid vaporization into gas, when gas is condensed, again it convert into the liquid. When the liquid is frozen, it becomes the solidification and changes into solid. And when we heat the solid, or some solids directly converted into the gas by the phenomena of sublimation. The gas is converted into the solid by the deposition process. Solid can convert into the liquid, liquid can convert into the gas, gas is converted into the liquid by the condensation process. These are the interchanges or the interconversion of the matter. We can see here, the solid can change into the liquid, first point. Liquid can change into the gases, second point. Gas can change into the liquid by the condensation process. If we freeze the same liquid, it start to change its state into the solid, and solid can directly change into the gases by the sublimation process. If we can see that gas is directly convert its state into the solid by the deposition process. It means all these three matters or the matters can interconversion here by changing the temperature or pressure. When it will happen, when we change the temperature of the temperature or pressure, they can interconversible. Okay, next point, evaporation. The change of a liquid into the vapors at any temperature below its boiling point is called evaporation. Vaporization is the different and evaporation is the different. I will tell you the very good example for this. You will see your mom is going to wash the clothes and she hang that clothes in sunlight. After a few hours, we see every wet clothes is now dried. How it is possible? It is possible because of evaporation. when the heat, when the light, when the heat is fall on wet clothes, the water which is present in the clothes start to evaporate. Evaporate when at a temperature, at any temperature we can say. Our mom is going to hang the wet clothes at 20 degrees Celsius. In the 20 degrees Celsius, we see our clothes become dry. In 30 degrees Celsius, our mom is going to hang the wet clothes outside. After hours, after a few hours, we see that wet clothes is converted into dry clothes, where the all water is gone from that wet clothes. It went in the atmosphere by the phenomena of evaporation. That is only the definition is here. The change of a liquid into vapor at any temperature below its boiling point is called evaporation. I hope you people are going to understand this. Next one is that factor affecting on evaporation. First point. First we see the title, factors affecting the evaporation. What factors affect on evaporation? First point, increase in the surface area. Second point, increase in temperature, increase the rate of evaporation. When we increase the temperature, then the rate of evaporation is also increased. For example, if we dry the cloth at a 20 degrees Celsius, if we increase the 20 degrees up to 30 degree, then the rate of evaporation is also increased here. Third point, increase in the humidity, decrease the rate of evaporation. When there is a high humidity in the atmosphere, the evaporation process or the rate of evaporation is decreases. Why? Because humidity means it's already there are lot of water vapors in the atmosphere. Automatically the rate of evaporation goes on decreasing. Fourth point, increase in a wind speed, increase in a rate of evaporation. If there is no wind, our mom going to hang the wet clothes outside, it takes some more hours to get dry. Why? Because there is a low wind. When there is a high wind, our clothes start to become dry earlier or faster. Why? Because where there is a wind, there the rate of evaporation is high. Increase in the wind speed, it increase the rate of evaporation. Okay. Thank you for watching my class. If you like this class, please subscribe and give like and share. Today we discussed lot of the things. From beginning we are going to see that one by one. That is, today we discussed that is the matter in around surrounding. Yeah, that is the first point. What will be discussed? That is the what is a matter, how matter is made up of, and the classification of a matter by the Indian philosopher, the classification by the Indian philosopher, the classification according to their physical state. We see the classification by on the basis of chemical compositions, and today we saw that we discussed about the state of matter. We saw the properties of a solid, we saw the properties of a liquid, we saw the properties of the gases, and we saw the physical nature of the matters. What are the physical nature of the matters? Whatever they are, solid, liquid and the gaseous. And next point is change of a states. It means the change of a state of a matters. We saw here the ice solid can convert it into the liquid, liquid can convert it into the gas. Here gas is converted again into the liquid, and liquid is converted into the solid. And next point we discussed here about the melting, that is nothing but a fusion process. And next one is the latent heat of fusion we discussed, and again we discussed about the boiling and the latent heat of the evaporation and sublimation and the effect of the pressure on the gases. And we discussed the interconversion of the three states of the matter. This is a very important point here. Next, that is the evaporation and the factor affecting on the evaporation. This is the first unit. Okay, if you like this video, please subscribe and like and share as much as you possible with your friends. Thank you very much.